Okay, so this is a continuation of the last video. All the answers are here on this review, so don't be afraid to look at those. But I just picked out a few important questions, so I wanted to make sure I shared them with you. All right, so now I give you a function, f of x and g of x, and you're supposed to find f minus g. Please, when you have these, make sure I would square these out first. If you don't know the shortcut, make sure you write it twice. So 4x squared plus 4x plus 1. And this one would be 4x squared minus 12x plus 9. All right, so we're going to take f minus g. So that means we're taking 4x squared plus 4x plus 1 minus parentheses 4x squared minus 12x plus 9. I like to do that so I can change my signs, plus, minus, because I'm subtracting. So now the 4x squareds, they cancel. They're going to cancel out. Positive 4x and positive 12x makes 16x. Positive 1, negative 9 makes minus 8. So 16x minus 8. So be careful with subtracting. Make sure you change the signs. All right, this one, this is way back at the very beginning. We're going to factor, and then because it's divide, we're going to flip because we multiply by the reciprocal. So the numerator doesn't get to change. The denominator, I notice they both have an x squared in them. I'm going to factor that out, and I get x minus 1. Now I'm going to multiply. And flip in the same step. So now I'm going to do the denominator. I notice they have an x in common, x minus 1, and the numerator, trying to trick you, x squared plus y squared cannot be factored. X squared plus y squared. Only the difference of two squares, not the sum. So my x minus 1s would cancel, and this x cancels with one of these x's. So I have x plus y over x times 1 over x squared plus y squared. So I now put them together, and I have x plus y over x squared plus y squared. Okay? All right. So no factoring can happen there. All right, find my asymptotes. We'll find asymptotes and wholes. So let's do vertical asymptotes first. They have to do with the denominator, right? Where is the denominator equal to 0 as long as we can't cancel? So notice we can't cancel anything, so I know there are no wholes. Wholes only come when I can cancel. So my vertical asymptote happens when x minus 2 equals 0 and when x plus 5 equals 0. So x is either equal to 2 or x is equal to negative 5. Those are my vertical asymptotes. My horizontal asymptotes, remember, it has to do with the degree. The degree of the numerator is 1. The degree of the denominator is 2. So for horizontal asymptotes, the degree of the numerator is 1 and the degree of the denominator is 2. Well, when the numerator degree is less than the denominator degree, I know that it's y equals 0. When they're equal degrees, I look at the leading coefficients. When the top is bigger than the bottom, there is no horizontal asymptote. Remember, you can also graph it and kind of double check that. But I would write down the rules for my horizontal asymptote. Remember, there were 3 of them. I'd write those down so I could use that for my final exam. All right, so maximum height and time. So I want the maximum. So the first thing I look at for this one, and you can read all the words up on top, I notice that this is an upside down parabola. And so I know the maximum height is going to be right here. Okay, so the height, if I were to graph this, the height would go on this axis, which is s, I should say, not h. S for distance, that's what they use in physics. And then t is my time at the bottom. So I'm looking for this point right here. I'm looking for these coordinates, which is my vertex. So you can use your calculator and find the maximum if you want to do that. Or you can remember that your axis of symmetry is x equals negative b over 2a. So the time, which is the x, is going to be negative b, which is negative 20, over 2 times negative 16. So negative 20 divided by negative 32, 20 divided by 32 is 0.625, which I think is some special fraction. Is it 5/8? Yeah, 0.625. So t is 0.625 seconds, or 5/8, which is not going to be on your test because it's easier to type 0.625. So that's the time at which it gets to the top. Notice it's not very long. And then if I were doing, if I had to find the maximum height, I would just plug it in. Negative 16 times 0.625 squared plus 20 times 0.625, and I'm running out of room, plus 6. Let me move this over a little bit. Let me take the whole thing instead of just part of it. Well, there we go, and I lost the negative sign this time. All right, so negative, and let me get rid of that negative sign because it looks silly. Okay, so, and then plus 6. So I would type that into my calculator, negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And I get 12.25. So 12.25, and I'm assuming it's feet, is the maximum height. Okay? And you can remember, you can find that with your calculator when you do, second calc and find max. So you can do that with your calculator. The x value is your time, and the y value is your height. All right, so now I want eco to be a better deal. I wrote these down. So x is going to be the number of hours. So Mac, I would have said 150 plus 20x is for Mac, and eco is 275 plus 12x. And I want eco to be a better deal, so eco has to be less than Mac movers. So 275 plus 12x has to be less than 150 plus 20x. And then I just solve. So I would subtract 12x just to make it positive. 12x, and then subtract 150, subtract 150. So I get 8x is greater than, what is that, 521? 125. Divide by 8. 125 divided by 8 is 15.625, 15 and 5/8. So 15.625. X is less than, did I do that math right? Yeah, I think so. What is it? 15.625. 15.625. So because I like the x on the other side, x is going to be greater than 15.625. So if it takes me more than 15.625 hours, then that's when eco is a better deal. Okay, so 61, I think this is, it's almost the last one. So I'm going to change colors because I was using that to draw this one. So I graphed it, and I had to change my window so I would get everything in. Okay, so here's my minimum here, and I did, on my calculator, second calc, and I did maximum and minimum to find this. So this was at 0.10, so 0.10 is my relative minimum, and up here at the top, this is 4 2/3, or 4.66666, so 4 2/3, comma, 60.8. And that wasn't an obvious number, so I just wrote 60.8. And you can just round them, whatever. Increasing, this is the area that's increasing. Remember, it's all about x's. So increasing is from 0 to 4 2/3. Okay, that's my increasing. I'll change colors here so we can have different colors. Decreasing is this section and this section. So decreasing is from negative infinity to 0 and from 4 2/3 to infinity. Those are decreasing. Negative, the only place that's negative is here. And so negative, which is f of x, is less than or equal to 0. That's at 7.2, said the calculator, for that x value. So I'm going to say from 7.2 to infinity is where it's negative, and it's positive every place else. So positive would be from negative infinity to 7.2. Okay, that's when f of x is greater than or equal to 0. Okay, all right, and now the 9th degree, this is the last question, touches at those two places and it crosses at 7. I already figured out that it's going to have a leading coefficient that's negative. Okay, because that's what the word said. So if it touches here, that means x minus 4 has to be to an even power, and x plus 2 has to be to an even power. Remember, when it touches, it's even power. Crosses at 7, so x minus 7 has to be to an odd power. It's got to add up to 9 because it's a 9th degree polynomial. And it's going to be negative in the front. So negative, let's just start with x minus 4. I'm going to make this 2. X plus 2, I'm going to make 2. That makes a total of 4. So then I would make x minus 7 to the 5th power. But it doesn't have to be that one. I could have had negative x minus 2, x minus 4 to the 4th power, x plus 2 to the 2nd power. That makes 6. And so then I need 3 more, which would be here. So there's a whole host of answers. It's multiple choice. You just have to pick the right one. I know my leading coefficient is negative because if I go back up and read the words, where were they? Here. So, and it goes to positive infinity as x gets very small. And it goes to negative infinity as x gets very big. So that's how I knew it goes to negative infinity as x gets very big. So that's got to go this way. And it goes to positive infinity as x gets very small. That's a negative leading coefficient because it looks like the slope is a negative slope of a line. All right, well.